Okay guys, 7.3, we're going to be using decimos quite a bit. This might take a little bit of time to really go through the graphs of trig functions and the relationships among the transformations, but that's okay, we can chunk it into pieces if necessary. These are, this is a learning target that seems to come up quite frequently on the IB exam. It's also something that is pretty important in order to be able to understand later concepts in calculus. So make sure that you really feel comfortable with trig functions, what they are, and what they look like when graphed. So we're going to look just briefly at the notes here, and then we're going to go over to decimos. And if you'd like to take additional notes on decimos, that's probably a good idea. You can just use this initially to have sort of a scaffold for looking at when you're doing your notes, but do make some more notes that are meaningful to you when you are doing the decimos videos. I'm also going to include a video on my playlist which shows how the unit circle tracks into being the sine and cosine waves, so just kind of review that briefly and look at what that looks like if you're struggling at all with how the sine and cosine graphs come to be graphed the way they are. So we're going to look here briefly at what's considered one period for sine and cosine. One period can begin at 0 and go to 2 pi. Okay, so it's this section. You could also begin here at pi over 2 and go 2 pi ahead of that. So it could be, what would that be, 5.5 pi, 5/2 pi. So there's lots of different ways you can look at a period, but remember it's always going to be 2 pi long when you're looking at the parent function. We can do transformations on the period also, but be careful. Your parent function has a period of 2 pi for both cosine and sine. Okay. So cosine is this, now let's get all my colors out so that they match. Cosine is this one right here. When you think about its relationship to the unit circle, it's the one that begins at 1 and then it goes up and it decreases until you get to 0. So if I'm going to make a little sketch of my unit circle here. Cosine begins here with the value of 1 and then it goes up and then it goes down and then it actually goes back up to the right there, because cosine is the x value, right? So it's going to decrease and then it's going to get into the negative values and then it's going to come back up negative till it hits 0. Okay? And then it's going to increase back until it hits 1 again. So no matter what's going on here, when you're looking at the parent function of cosine, you're going to oscillate between 1 and -1. Okay? There, theta is an element from 0 to 2 pi in this graph. Now, even versus odd functions, we've talked about them in the past, but I'm going to briefly just touch on what that is. We're going to look at it in one of the videos on decimos also. An even function has symmetry over the y-axis. That is, if I plug in -x, or I were to graph the function f of -x as compared with f of x, I would be looking at the exact same function. I have a specific decimos activity in which we're going to look at that. Okay. However, down here, sine is an odd function because it is not symmetrical about the y-axis. It has symmetry about the origin. So if I were going to graph f of x and f of -x, if I were to multiply f of -x by -1, I would get the same graph. And that might be a little bit sketchy to think about at first. You might want to leave a little box right here to make a note to yourself of what that means when you actually look at the graph. So make sure you reflect a little bit on what that means to you. Okay, same graph in terms of period here. I'm going from 0 to 2 pi. I'm still oscillating between 1 and -1 for my range. And my period here, my initial value for y starts at 0, because in this case, when I'm thinking about the unit circle, sine is my y value. So it goes from 0 to 1, and then it goes back down to 0. So it goes from 0 to 1, back down to 0. Then it goes from 0 down into the negative zone. That's this part right here. and then it goes back up to positive 1. That's this part right here. So if I were going to go A, B, C, D, I would be looking at A, and then B, and then C, and then D. So that would be the components of this equation in relation to the unit circle. Okay, so we're going to go over to Desmos here, and we're going to look at what this looks like on Desmos. You have to be patient with me for just a second, okay, guys? All right, let's go to sine and cosine as even and odd functions. Again, I can share any of these with you if you are interested. Okay, so these are all clear here, so nothing is showing as a function right now. But let's look at sine. So here's sine, and here's sine of negative x. So if I was talking about f of x and f of negative x, you'd see that they look like they're kind of reflections of one another. So if I were to multiply this by negative 1, oh, look, they're the exact same thing. That is the definition of an odd function. I'm going to hide those guys. Now let's look at cosine. Cosine and cosine of negative x, look, they're the exact same thing. I don't have to multiply it by negative 1. There's no transformations needed. When I plug in x and when I plug in negative x, I get the exact same graph. That is the definition of an even function, okay? When you are doing these algebraically, if it says to prove that something is even or odd, you're going to do exactly that. You're going to plug in negative x for your function, and you're going to simplify it in some way to show that this and times negative 1 is equal to this, or that this function and this function, by definition, are equal. Now, just take a second and glance over here at tangent. What do you think tangent is? Take a second and reflect on that. I'm not going to answer the question, but if I were to say times negative 1, what happens? What does that mean? So answer that question to yourself. If I have tan of x and negative 1 times tan of x, and they're the same when they look like that, what kind of function is the tangent of x? Is it even? Is it odd? Or is it neither? Okay. All right, let's go back to our presenter here. We're going to look at the next page of, so we're going to just run through this real quick, and then we're going to come back to Desmos. So make this big here. Let's see if we can get it to be a little bit clearer. That's a little better. So transformations of trig functions. This should be review because it's just transformations. We've talked about transformations a lot over the last few years. So we have vertical shifts, we have horizontal shifts that happen in the opposite direction, we have reflections over the x-axis, we also have reflections over the y-axis. That's this one down here. Okay. I have vertical stretch. A is referred to as our amplitude when talking about trig functions. Okay. And then here is what I would consider the trickiest of all of the function transformations, which is the horizontal stretch. So horizontal stretches happening here inside the parentheses. It's an operation on x, and I'm going to call it b. Okay. Now, if b is between 0 and 1, or the absolute value, I guess, we're looking at a horizontal stretch. So if this happens, I'm going to get wider on my period. If b, or the absolute value, is greater than 1, absolute value of 1, I'm going to go shorter. So we're going to look at that here on Desmos and kind of view what that looks like. What does that look like? All of these different